Hello everyone, this video will show you how to drive a slave clock basically by generating with the Pi 0 and the right power supply a 24 volt DC pulse every minute to drive the video you can see, to drive the clock you can see on this screen. So it's a slave clock, you can see it working in another video, but in this video I'm going to focus on giving you the schematic, a simplified code. I've basically simplified the code, cut it by 3 in length, and it does the job just fine. I will provide also the PCB layout, the printed circuit drawings, and a couple of pictures of the board with the components soldered on the board. Okay, so that's the clock we want to drive. That's our schematics. So basically you've got your Raspberry Pi or Pi 0. This is the push button which stops the program running. So when you push on this push button, you drive this input GPIO 18 and you stop the program. This is the LED which will be lit each time every minute a pulse is sent to drive the relay, and the relay will allow your power supply to drive your clock solenoid. And so that's your clock solenoid. Yes, this switch allows you to have this part running whilst the power supply is disconnected from the clock. That's really useful when you change time from spring or in fall, when you go 1 hour forward, or when you stop, you have to stop the clock for an hour. All you have to do is use this switch, you let your Raspberry Pi 0 running in the background, and when the clock is on time again, you close the switch, job done. Okay, so that's really convenient to separate, to keep this part running without driving your clock. So that's the schematic. I think you saw it enough. You can always pause if you want to have another look at it. Let me capture it. Okay, so that's the schematic. For the code is simplified, so it's much shorter. I'm just gonna stay here again. There is a long version in a previous video where you can do copy and paste. It's a very simple code. You define your input, which okay, 8 as an output, fair enough. That's the one driving the relay. That's the input for the push button. And after you've got an infinite loop which generates every minute a 200 milliseconds pulse, which will close the relay. And that's about it really, to be fair. Okay, so now you've got the schematic, the code. Let's have a look at, that's gonna be the PCB layout. You can see your resistor with the push button here for the GPIO. That must be 18. There you've got the LED driving the resistor, and there you've got your 5 volt DC relay with the 24 volt DC power supply going there. This is where you put the solenoid of the clock. So this low voltage part, 24 volt DC part, and you've got there the switch which allow this part to run without driving the output. So that's when you change time in spring, when you go forward 1 hour, or in fall, when you go backward an hour. You can keep this part running, disconnect the output, and basically wait that the clock is on time again before switching this back on. Okay, so that's the PCB layout. Once you've got the PCB layout, you're gonna need, that's actually the printed circuit. So on this part come your pi 0, and there if you look at the if you look at the PCB layout on the previous screen, you can see that where the different components goes. Okay. Talking of which, that's how it looks once you've got the pi 0 on the board, circuit board with all the components soldered. That's the back of it, and this is just the video with the pi 0 driving the pulse. This is the push button to stop the program running, and this is the solenoid output, and you put a 24 volt DC power supply here. Okay, and that's about it really. Alright, well, good luck.